7:20. All right, I think we have much more, like 6, 7 more days of lecture only.
Yeah, close to that.
Yeah, it might be a little much. So we got to plow through chapter 5, which means there's no homework assignment today because we're only halfway through the full derivations. There will be one on Thursday.
I think we only have 4 more days. Do we have any?
Today, Thursday, you've got a Tuesday the next week.
Wait, do we have Tuesday next week?
Yeah, so you've got 5 more days.
Including Sunday.
Yeah, including the day. Let's go. And one of those days is going to be a test. So, the other thing that I want you guys to keep back in mind is to whether or not you want to move the exam in this class. This class is small enough that I probably won't, or the administration probably won't find out if I move the exam. So I'm up for moving it later in the week for you guys.
Wait, when is it currently?
I think it's on Tuesday.
I think it's on Thursday.
Is it?
Yeah, because we're at 3:30 time, which means odd times go on the basically the second time the class meets.
Oh, that'd be perfect. Does anybody have their syllabus? I might have put it on there. I think there's some of them.
Yeah, because
Was it red?
like Tuesday is like a Tuesday from 2 to 4 is the time reserved for classes that start between 2 and 3.
That does make sense. So
It's Thursday.
I had even listed that. Awesome. Okay.
Does that matter? Perfect. I like the they work.
So that means we've got 4 more days of lecture, and then we've got our exam will be on the final Thursday, and then another week. I'll have your exams graded, your fourth exam graded for you by the beginning of the week. So you won't have to worry about this class, so presumably the rest of yours are done.
I got a question.
Yeah.
Based on this, okay, I know your regular class. Those are going on Monday. Your evening class. When will their final be?
I do believe that's on Monday as well, because any classes that start after 5, I think you go to first day of the week.
So what you're saying is, if we want, would you be willing to do a study thing on Wednesday night before the exam?
Yeah, I can do that.
Okay. Or Tuesday, whatever helps for them.
Yeah.
Since we'll actually be your only class at that point left.
Like I said before, I'm strongly leaning towards making your final exam a large chunk of definitions and whatnot. Just what is this for, things like that. Also, because there's a limited amount of time for that. This third test is also possibly going to be half take-home, half not. So, because if I want you to do any derivations at all, I want you to have more than an hour's derivation. It's just not really fair to do it otherwise. All right, so chapter 5, bound cases. Let's get going. Bound cases. What do you mean by a bound case? So chapter 6 is unbound cases. Chapter 5 is bound cases. And this is just fancy physics speak for some very simple things. Let's take.
You know, I don't trust your definition is simple anymore.
All right, so let's take a block that's attached to a spring. If we stretch the box out and we let it go, it's going to bounce back and forth on a spring. Regardless of whether or not it's a frictionless surface or not, the box is bound by the spring. And so when we talk about bound states, all that we mean is that there are external forces that are trapping something. The other simplest case would be something like this. We've got a ball that's inside a valley. If I start the ball in the valley here, even assume that it's perfectly frictionless, there's no drag, the ball is going to go back and forth in between here for eternity. Now, assuming that there's friction or anything like that, it will slowly slow down to the point that it's down here. Nevertheless, there are boundaries. It is a bound case because there are forces that are keeping it limited. Now, let's take a case where we have something that is unbound. Just take a hill like this. Let's take a particle that is going in this direction, and it goes over the hill, presuming that it has more kinetic energy than this gravitational potential energy in this height. The ball will go over the hill, and it will keep going. Okay, this will temporarily slow down the ball. And I say that because in the frictionless case, it'll be moving the slowest up here, but then when it gets back down here, it'll be back up to the initial that it started with over here. If it's a frictionless case, it will speed back up. So this is an unbound case, where there are external forces that act on it, but nevertheless, they do not So we're going to start with these found cases, where something was trapped. Which might sound more complicated, but in fact it is in fact simpler. We know.
So we're
I
doing
even brought an eraser today, so I can do this quickly.
So we're dealing with springs again?
Say again?
We're dealing with springs again?
No, not necessarily springs. In fact, what we're going to deal with is something